Hello guys, it's me, Damien, for some know me as Dexter. I'm gonna try to basically make the case for ICP. Um, I, I like to try to explain the paradigm shift that they making and what they been able to do. Like um, their accomplishment is kind of like you can't comprehend it um, at once because it goes against everything that you know about like crypto, etc. So you don't mind if I smoke, of course. It's just a cigar. What I like first to address is we need to see how the things today work, like the whole internet infrastructure, how you are able to see this video on like Twitter, how this works, how does my video goes from my computer or the servers to your screen. How does it happen? So first we'll check this in Infopedia. What you see here is the whole world internet. So this is all the data centers, all the switches, all the cables. So like you have like Atlantic cables, etc. who run like from coast to coast that are hosted on data centers, and then some data centers spread it out, and then you have your lines, and then maybe you're living here somewhere in fucking Ohio or something, and then your internet provider providing you this internet, but it's connected through the lines here, and then somewhere it goes here to New York, and then it comes to here, maybe to Amsterdam or wherever I'm basically connecting us all. So this is like the whole um, world internet, how it functions. So this is like how the data goes between data centers and cables to switches, internet service providers, and then comes like to your screen. I've prepared some images, so if we can go through them. So you understand first, like we are connected through cables, data centers who host your data or the data of Twitter, Facebook, whatever. Those are like big physical places who host, and then you have like the connections, etc., who provide the service for you to see the video, for example. This diagram, it's based on this. So you have the ICANN, that's like the World Internet Organization, kind of. I'm not sure what it stands for, but ICANN branches out to like 5 different like bigger sub providers, and they branch out till you get to your local provider, and then they provide your internet. So you have like this, you have like a big ICANN cluster. Those are all like all the cables and all the bigger data connections here. That's your ICANN. Then you have your international service providers, so that are like the Lansing here, APNC for like Asia Pacific, African nations. They have their own like internet providers, and then they connect to hosts. From hosts, you get to the users. Those are like your first steps to understanding the topology, the internet infrastructure as a whole. I have like a different image here. it's basically showing you like how the Amazons or Google data centers work. So you have your those are the lines, public internet peering, like we see here, that connect different data centers and then different ISP providers who then serve you that internet. So as you can see here, you have like big clusters. That's what we see here. You have like big clusters of internet service providers like Comcast, AT&T and stuff, Google Cloud, Amazon Web Services, and many others that are connected with those cables. So all those data centers connect with those cables eventually, and then they interconnect with each other on the continent, or for example, if you go to Europe, Belgium, whatever, those cables come in here, and then eventually they branch out here, and then everything is connected through the cables. It's important to understand this because I like to show what the Definity Foundation of ICP has been able to do, like how it functions right now. So if we go back to my images and diagrams, so we understand that we have a interconnected network with different providers, like a big organization called ICANN. It's like the overreaching organization. Then you have your ISPs underneath the hosts, and then the hosts serve to the users. So here's like a simplified image, not per se simplified, but like more in depth. So this is your service provider, so that's on this level, who runs the protocol TCP, called Transmission Control Protocol. Basically, they have made that transmission control protocol because they needed to have a common like language to speak. So like you can understand me today in English. The different internet service providers like around the globe needed like one language to speak. So they made TCP. So on that, that's like a layer. So that's a common language to speak, and every internet service provider runs that layer now. So it's commonly accepted. They agreed on, okay, those are the rules we're gonna abide by. Everyone needs to play with those rules, so we have like one rule set. As you can see here, so you have your edge providers. So that will be like those clusters here, your hosts. And those hosts have like maybe firewalls, maybe the different like private networks that serve like for here, for example, a residential home network. So that will be here. The hosts serve that network. Then you can see they all use that protocol, the TCP. That's like a internet protocol for everyone to use. And then this is how it's interconnected. If we go here to the right, this is like the diagram on how your devices interact with the internet. So you have your mobile phone, or for example a computer that has layers. You have your user profile, the context system, application network. This is like the stack of your iOS system that has like the context, or your information data, your user profile, that runs the application. That application interacts with the internet, and then from the internet you go to the core network that has the monitoring cloud, and in that cloud you have the ISPs, the user probes, monitoring and management, etc. So so from your device, so you will be here. Your data is then sent to this national USP, or internet service provider, over that TCP protocol. So over that common language, they say send your request, your data, your tweet, whatever. And then from the user, it goes here. And for example, let's say for example Twitter, or X. X has like data centers all over the world because they want to serve real-time, fast content for everybody at the same time. So they have like a data center maybe here, like in all the countries possible. They have like their data centers so that they can sync up in real time and host their data on their internet. Okay. So if you would send a tweet, first it will go like to the host, then the ISP would index it where their data center is, and that data center would communicate with all the other data centers over that internet. So for example, if you take me, I'm here in the Netherlands. If I upload my this video will go first to the quickest data center around me. I think it's in Holland or in Germany. Then the data center is gonna communicate like with other data centers through those cables that I have uploaded this, and then they can sync up. They can serve you this video. That's how it works. So it will be replicated across the data centers for backups, etc., but also for quick serving. And then you have like complex schemes, like some videos get indexed at only like half, or for example with I know Twitter indexes like syllables in a different way, and then that gets stored in a separate way. It's like complicated schemes to basically serve you the quickest way and with the most efficient way. If we go back to my diagram here, let me see. Right, so we arrive here at the transmission computer protocol. That's what we were talking about, like the common language. That's how the applications on the internet communicate. So they communicate in one language that's called TCP. You have different languages, but for now we will keep it simple and we say they communicate with the TCP protocol, been able to achieve. So this is your traditional Web2 internet ICANN. We will switch over to the ICP network because ICP is not a blockchain. Many people misunderstand it, I think, because it uses blockchain technology to strengthen itself and the whole network. But it's a network. It's a network. I've been trying to like make the network here with all the with all the providers that we have here. So if we look at this picture here and here, oh, we see that this is the network of ICP. ICP has let's see 136 node providers. So that means that there's 136 data centers around the world that run a specific language that's called the Internet Computer Protocol, and then they interconnect with each other. Providers, aka like data centers that run the common language of ICP. ICP stands for Internet Computer Protocol. That's like a language for them to speak with each other. So if we go back to the ICP, this is what you would know maybe or see. The top layer of ICP has canisters that maybe run an application. This would be maybe your meme coin or exchange or a library or whatever, like a data storage. Those are your canisters that are on top of this protocol. We go down. I've made some nice graphics here. You can see that the data centers are down here. So they host together like this big canister, the big cluster. They host together this cluster, through the protocol of ICP, they create subnets, and those subnets host the canisters. You can see here. So we have the datasets of data centers. They create together because they talk with a common language. Those subnets that work together to host all the data, all the network stuff, everything in one setting. So where you have on the traditional internet, you have your application layer, your transport layer, and in between that you have also your languages of Python, of communication layers with different providers. ICP takes actually like everything and it puts it in one spot. So your application layer goes out the window, your transportation layer goes out the window, and what we only have is your internet layer and your link layer. That's what we see here. You have your internet computer where you can then host your canister and would live on top here. That will be hosted with the ICP protocol, that's the common language. And underneath that, you have your IP internet, so your layer, your internet layer, and then your link layer directly. So the link layer is all the data centers that are directly connected through those cables here. And then on top of that, you have your IP internet. So your data centers are connected with those layers. And then they speak a common language. And then by speaking that common language, they create the subnets. Those subnets here that we see, there are 37 subnets on the internet computer that host all those canisters. Let's see that there, how many canisters there are. Let's see, there's almost 900,000 canisters. So there's almost 900,000 canisters that are here in this on the top layer that are supported by 37 subnets that are created by the 136 data centers around the world. So together they create this protocol that allows you to interact with each other at once, like the first internet created TCP to have a common language to talk with each other. The ICP has made the ICP protocol to basically say, okay, you have your data center and underneath your data center you have your link layer. They can really like make their own cables or whatever. So you have your first, that's your link layer, your last layer. On top of that, you have your data centers and your internet. And on that, above that, it's like one chunk. So the data centers and the link layer, that's like one chunk. So you don't need to worry about like this application speaks one protocol or this application speaks another protocol, because it's hosted at once in one setting, talking like one language directly on the hardware layer, not on the software layer where you have like for example you have like this website. This website is hosted on in some data center. It runs like HTTP, it runs like HTML, and then it's created and transformed through those layers. On the ICP network, what you have is they all talk one language from the back end and the front end. So we see here the front end, but maybe the back end is hosted with Flask or whatever in Python. There's like the diagram that would be Rust or whatever. But those are the two different like things. So you have your front end, your front end would talk to the back end, and they would create this what we see here. What's different on ICP is that the front and the back end is hosted in one canister at once. So you don't have like your front and your back end, you have like your front and back end in one. When you create a canister, you need to see it as a virtual private server where you can like hire VPS on Amazon Cloud or Google Cloud. You hire like a piece of a computer in a data center that you can host your applications on, whatever. That's basically what a smart contract is on the ICP network. You hire a piece of compute, you hire a piece of the internet asset of like real estate on the ICP network by creating a canister. The greatest analogy I've seen is this one. Is 2009 with, of course, Bitcoin. That's like the digital gold. They created the value. They said like, okay, the money system needs to be changed. How are we gonna change it? And Satoshi Nakamoto and different people came up with the solution of money backed by energy called Bitcoin. Then we had Vitalik, who said, okay, what if we could create Bitcoin, but we can also develop like applications on it? That's where Ethereum comes in play, where you can have NFTs or different applications, the Uniswaps, whatever, like programmable contracts that can be broken. But Ethereum is hosted also in data centers, and it's not like it's decentralized, but because some are like hosted near each other or in one cluster. Ethereum still runs like a hybrid system. It has blockchain technology, but it's not a network. Where ICP Computer Protocol has made its own network. Like Bitcoin has made its own network with all the nodes running and all the miners mining together, creating one big network, creating the hash rate. ICP has made its own network. So they made the ICP Internet Protocol network, which basically gave everybody the ability to rent, because you if you make a canister, it's yours, but you need to pay for it to out of cycles and then it goes offline. It gave you the ability to rent a piece of that network, and on that piece, like a small chunk of your real estate, you can build whatever you want in their language. So if you know Motoko, if you there's like integrations of Python now and Rust and etc. But if you can build in their language, then you build on top of that stack, directly building on the infrastructure, directly building on the hardware layer and on the data centers. So that's the biggest innovation. Between Bitcoin and Ethereum, there was no real innovation because nobody has made their own internet. Everybody built on top of like a Google Cloud or Amazon Web Services, still relying on them. It's like from Bobby, he has explained in great length. But that's basically how they have innovated it, because they said, okay, we are not gonna rely on third-party services or third-party data centers or cloud services. We will be our own cloud, directly sitting on that link layer, directly sitting on those, basically on those cables, because between those cables and your applications, only like the data center in the subnet. That's why ICP is so unique. Well, between like a Solana application is hosted on maybe 5 servers in Amazon Web Services, and that's the whole network. So that the blockchain is only the application where the ICP protocol is the whole device, and that device runs directly on the internet. For those implications, it's not it's not it's not easy to comprehend what implications it has, because this has never been done. It's totally new, and a lot of people don't understand how it works. That's why ICP is the only protocol that can run a full 8 billion parameters model in a canister, because a canister can be really compared to a smart contract, because the canister is the full device. It's a full VPS that can host that model for you in that whole data center, in that whole cluster here. Let me see. Like we see here on that whole network, because they all talk with the same language, they can communicate with each other. So, for example, if we would have here one application like AI model hosted here, and it hosted in a canister, and it's public. Maybe it has some functions that you can call. So, for example, let's say we have this canister that hosts an AI canister, and that we can interact with that canister in some ways, like tasking it with instructions. Let's say you have a different canister. So this is like an application that was made by Decide AI. They hosted this model, and you're free to interact with it through that ECP protocol, where on that whole network everything speaks with one language, so they can talk with each other. So let's say you have here like your different application that lets users make autonomous trades. So you have your account, you go to it, maybe you deposit like USDC, and that USDC can be used to invest for. Let's say you have like a different application here that's like a swap. It's like an exchange. It's hosted also as an application. It has liquidity. It has like other tokens. What is so unique on ICP is that we can interact with this canister. This canister is interacting directly on that network with. Let me grab this. With this canister that has the AI in it, and then the AI can autonomously interact with the swap for you. So you make a call to the AI canister. That AI canister then makes a call to the swap network, and then that swap network autonomously can send your canister where your account is, your tokens or your swap or your trade or whatever. So because everything is interoperable, and they speaking the same language of ICP, you can do crazy things that are for now incomprehensible, because that's not the paradigm of crypto or blockchain. Because on the blockchain, what like a Solana is just like a one canister that's hosted on some on some host here, not on the ISP, not on the ICANN. Solana, you're interacting in Solana with a host. This is your Solana, this is your Ethereum, this is your Aptos, whatever. Pick your chain, but ICP is basically the ISP provider, almost the ICANN. They created their own private network that sits directly on those data centers that interact with the cables that connect everything. So they created their own private network, and then open sources for everybody to interact. So that's why it's called the real Web 3, the Internet 2.0. Because if you host something on ICP, you have HTTP outcasts. What that means is ICP has made canisters on the edges of their network. And those canisters can not only interact within that network, those canisters can also interact outside of that network. So making a HTTP request to a website, to a Web2 service like weather service or weather API or Google API that can bring the data back to the network, and um, allow canisters to act on the data or work with the data. So that's the unique thing about the HTTP outcomes that are right now available, where the private network that has like the ICP language allowed outside communications two ways. So you can make a get request or post request, where you can communicate from your canister outside of this network to the normal ISP providers and back. So let's say you made this trade, and then you want to also notify yourself on the Telegram. That's possible through the HTTP outcast. So you would have like this is your application, your normal application, like a bot or your Telegram instance, where after this trade has been done, you would get the notifications through those HTTP outcasts that are outside of this network. And then you get your notifications on your phone or whatever you have your Telegram. But you don't run the ICP network on your phone, but it gets a call, like a notification, from that private network. It gets sent out to the normal network, converting it back to TCP, and then being able to communicate with the outside world. That is basically how the Internet Protocol works. So you have this is like the third invention, and for now I see very prominent future, and basically years that I'm thinking, and not like in weeks, months, or even years, maybe even decades. Because if you would look at, for example, like Apple, that started 1948 by constructing the first prototype, the Macintosh. They innovated, and then slowly but surely they became one of the most valuable companies in the world, because they did something different. They didn't go in the footsteps of the Android, where they built us on top of something. Likewise here, ICP and Dominic Divinity Foundation didn't build on Ethereum. They didn't build on the stack of Bitcoin. They made their own. So from the ground up, they made their own network, their own language to communicate directly with the Internet Protocol, and underneath that is the layer of those cables that can communicate. That's why ICP is so unique. Nothing compares. And because they did all that work, because they have created something so complex and amazing that it's kind of incomprehensible for normies to understand, like what they really did. You can do really cool stuff with a canister. Like I said, you can create your autonomous agents trading for you. It's basically the difference between what I just explained, like how the ICP model works. So you have your data centers and your cables, like illustrated here. Those do have the IP stack, so the Internet Protocol. That's like the common Internet language. And then you have the ICP protocol. So that's the Internet Computer Protocol, basically the world computer, that runs the whole stack for you. You don't have like on the left side you see you have your IP, and then you have your Amazon, of your Google Cloud or whatever, and then you have your other software that runs your applications and communicate with your devices. Here, ICP runs the whole stack for you, so front end and back end, with data storage, with persistence, with RAM, with everything that you would need to host an application. It's a full stack decentralized organization, basically, because the NNS that allows you to hire a piece of that network by creating a canister or hosting your data, where it's protected by the network itself. So if we look at this example, because you have like so many in between steps, you have your user, your host, your ISP, your ICANN, that host different layers, different application protocols, different languages. You have a lot of weak points that can be attacked. For example, your application can go down because you have a DDoS attack that where you attack your specific server where it's hosted. So a DDoS attack is where you have like 1,000 bots, and then they send requests all at once to your server where your website or whatever is hosted. That's like a small piece of the whole protocol where it's hosted. But they can protect you. The host can protect you. You can only be protected by Cloudflare, which reroutes or checks your the amount of users, etc. But inherently, it was not designed that way. So your canister, why it's unhackable? It's because it's protected with the whole state, the whole network. Like Bitcoin, you can't like double spend, because you would need to spend 10 times the amount of energy available to override the network. Here you would need to attack the whole network of ICP, so all those 136 providers all at once, and override them, or take them down to maybe get the keys, which is basically impossible for you to change 1 bit or 1 byte. That's why your canister, because it lives inside the network, not outside of it, like you have the different ISP providers, etc., who live outside of the network. ISP has made their own network, a whole stack, which protects everybody. It protects the data centers, it protects the subnets and the canisters. And the only thing that can go wrong is when those cables get cut, so then you don't have internet. But between them, between the data centers and your application, there's only one language, one protocol, which allows you to make, because everything is connected and everything speaks in one language, it's one network, it's one whole. It's not sub pieces here, a different protocol there, your DNS provider, your different hosts here, different hosts here. No, it's acting as a one piece, because that's how it's designed to. It was designed to make this top layer with all those subnets who host all the canisters. So that's why they're acting together. And basically that's the magic of ICP. That's how I fell in love with it, because I started to explore it, and I was first skeptical when it came out. After a while, I've realized that they are the winners. They are what others claim to be. They are the full stack. They are not like a Solana who is hosted on Amazon. Because Solana can't give you the ability inherently, because it's only been designed to send a 5 byte TCP package, which then is received and then it's run on the blockchain and then transported, etc. But it's only designed to for those small packages where in a canister on the ICP stack you can host 500 gigabytes of storage. So you have so you have your one canister that can store 500 gigabytes for around $5 on chain. On chain means in the network. So because it's the ICP network, which is supported by the blockchain technology. That's why we call it on chain, since it's one hole that runs the ICP protocol, and then it utilizes the cryptography, aka blockchain protocols, to keep it safe and communicate with each other. Everything lives within that network. Everything is one, everything is solid. There's no small pieces because you can't interact with something that's different on the network. It needs to be compliant with the network and it needs to be the same. Otherwise, it doesn't work. You can't deploy a canister that doesn't comply by the rules of the network. That's why you can't hack it. That's why you can't maliciously inject like code that would ruin a canister, because you are not the controller of the canister to deploy first, and if you want to deploy your code to a different canister, you would need to override the whole network or the subnet that hosts it. That's very difficult because the subnets are divided through, like we see here, through basically the whole world is hosting all those subnets, and you would need multiple entries to just like change one string, and that's not possible. That's not possible. That's why it's the ICP network. It's not blockchain. It's not a token. The token is a utility token that allows the network to function. For my second video, if more want to see, I would like to go in depth about applications on the ICP, what the NNS is, the neural network system. My analogy is basically this. You have seen the picture of the Internet Protocol suite. That's basically, this is basically what the ICP has done. Where on top canisters, you would see your HTTP, your applications, your email service, whatever, your SEC. And then you have your TCP. That's like the subnet. And then you have the Internet Protocol and the link layers. So those are like the data centers and the tunnels and the cables underneath the ocean that transport the data. I think if Dominic would be so crazy enough, he would and have the money, he would make his own cables and private network layer, but the link layer. But they have done something so amazing that not a lot of people want to recognize or can comprehend what the implications will be. So for the next time, I like to go into the Ethereum, the Bitcoin, how they host their own Bitcoin nodes and basically can interact now with Ethereum through HTTP outcalls and basically host like Ethereum smart contracts on the ICP stack. If you have listened the whole time, thank you very much. I appreciate it. Let me know if you would like to see more, if you would like to see content. There was my first video, so I don't know how it sounds, I don't know how it looks, I don't care that much, but I've done like a poll where people voted that they would like to see some content. So let me know if this was like informative for you. If I said something wrong, please correct me. There's a lot of like knowledgeable people, and I'm not an expert. I'm just an enthusiast, and I like the coin. I like the protocol. I like the network. It will be more clear why ICP is not your blockchain. It's not your token, because it's a network. It's a gigantic cloud where you can just rent like space, like a VPS. You can rent a little server that you can do everything on it, that is protected by the whole network itself, and nobody offers that. No Google offers that. No Amazon offers that. You can hack into a VPS on Amazon or Google. They can't protect you because that's not how they are designed to. So basically, that was it. Like I said, if you liked it, if you enjoyed it, please let me know. I will just post it on Twitter. I don't have a YouTube, whatever. I will just post it on my Twitter, and if you like it, thank you for watching. Recommend me about what would you like to see me talk, or what topics you want me to explore. For me, for the next topic, I was thinking like I want to go in some applications like Bob, like unique applications that can only be done on ICP. But I appreciate you for watching. Thank you for your time, and have a good day.